Okay, welcome to Chapter 11. Chapter 11 is really about one topic, and that is conic sections. So circles, ellipses, and hyperbolas. We've already talked about parabolas, so we'll focus our attention on these three new shapes. Now we're going to start with something that we've already seen, and that is the Pythagorean Theorem. So we're going to derive the equation for a circle from the Pythagorean Theorem. We're going to then use that to derive the distance formula, and that's going to be useful to us in other contexts as well. We're then going to look at the standard form for circles. Everything has a standard form, and if we can put something in its standard form, we can tell what it is. Is it a circle? Is it an ellipse? Is it a hyperbola? We're going to write the equation of a circle just by looking at it, and then we're going to be given an equation in all of its expanded glory, and we'll complete the square to find the center and the radius. So our first goal is to derive the equation for the circle from the Pythagorean Theorem. So here's the Pythagorean Theorem with the parts renamed. So there's no A, B's, and C's here. And the reason for that is that we're starting at the origin, the point 0, 0. And so from the origin, we're talking about an x value. So that's a horizontal distance. And a y value. That's our vertical distance. And then that hypotenuse, we're renaming it r, the radius. So when you do that, when you rename all these things, you get a form of the Pythagorean Theorem that's got two variables and a constant. The two variables are, of course, x and y, and the constant is r. Now, there's lots of ways of talking about a constant that you don't know, like r. You can call it a parameter, you can call it a literal. I'm just going to call it a constant. We don't know what it is, but we know it doesn't change over the course of the problem. So here are two examples of circles and their equations. So this first one, notice both of these have a center at the origin, at the point 0, 0. So we can see that their equation is x squared plus y squared equals r squared. So in this first example, the radius is 1, the distance from the center to a point on the circle, any point on the circle, is 1 unit. 1 unit to the right, we can see that clearly. 1 unit up, we can see that. And then all these points in between are also 1 unit away. Now this next example has a radius of 3, and we can see that by looking at the illustration. And we can see that its equation is x squared plus y squared equals 9. Remember that r has to be squared. This is the Pythagorean Theorem, where we're letting two parts of that, x and y, vary, and one part of that stay the same, namely the radius. Now both of these circles have a center at the origin at the point 0, 0. So the formula is relatively straightforward. X squared plus y squared equals r squared. Here's a GeoGebra file that illustrates that. I'm going to drag this point around, and as I do, notice that the radius stays constant, but that we can form a right triangle, and I've named the point at that right angle right. The radius is staying the same, the center is staying the same, but that point on the circle changes so that the center and the radius are constant. So we can also look at this numerically. So here are some numbers. Here is a radius of 10. You can see that that 10 follows the radius around. And then the other two values are changing. And of course they're changing because that radius is staying the same. Notice that, for example, here our x value is 7.35, and that's also the distance from the center to that right angle. The same thing for the y value. The y value, 6.78, is the height from the right angle to the point. Okay, our second objective is to derive the distance formula. And the distance formula comes to us from the Pythagorean Theorem. It comes to us from looking at the base and the height, and of course that shortest path, d, the hypotenuse, or what we were just calling the radius. We're calling that radius, or that hypotenuse, d now, because we're thinking of it as the shortest distance between these 2 points. Now, because we've got 2 points, that means we've got 2 x's and 2 y's, so we're using subscript to tell them apart. So this first point is the point x sub 1, y sub 1, and the second point is the point x sub 2, y sub 2. Now, if we want to find the distance, we need to find the length of the base and the length of the height. Now, that's simply a difference. So if you look at the x values, here's x sub 1 and x sub 2. So we're basically looking at where these live on the x-axis. And if we want to find the distance between them, remember that a distance is a difference, larger minus smaller. So there's our horizontal distance, taking the place of or x in the previous example. So we plug that in up here, and of course, according to the Pythagorean theorem, we have to square it. So there's the difference in the x's squared. Now, I had said larger minus smaller, and now you can see, well, it doesn't really matter that much arithmetically, because the moment we square it, we're going to get a positive however we do this. And the same thing for the y's. So if we look at the y values here, the first y value is y sub 1, that's our lower height, and the second, assuming we're increasing, and our second y value is y sub 2. The difference in those, that is the horizontal value, is y sub 2 minus y sub 1. So when we substitute those distances into the Pythagorean theorem, we get d squared equals the sum of the squares of the differences of the x's and the y's. Now that's really close to the distance formula. All we have to do is get the d by itself, so we take the square root of both sides. We're only interested in the positive square root because we're looking for a distance. Now, if we take that formula, d squared equals the sum of the squares of the differences, and we rename some stuff, we will get the formula for a circle with any center and with any radius. So we're going to do several things. The first thing that we're going to do with our distance formula is we're going to rename d as r, and that is the radius. So taking the place of the d squared in our formula is now going to be r squared. And x1, y1, that point, we're going to anchor it. So that point is no longer going to vary. We're going to say that that is a fixed point, hk, and hk is the center of our circle. Now that leaves us 2 other variables, namely x2 and y2. Now we're going to let them vary as x and y. We don't need subscript anymore because hk is our center. So if you take a look at what we've done, we've taken the distance formula and we have done some substitution. And with that substitution, we've got the standard form of a circle. Now, this is very powerful because it allows us to graph any circle, any radius, and any center. And a center and a radius uniquely determines a circle. So let's take a look at graphing circles with equations in standard form. So this next example, we're asked to graph this circle. We know it's a circle because it's the sum of the squares of those differences. Now remember there are differences. So when you look at that first base inside of the parentheses there, the x plus 2, that's x minus negative 2. If we think of that as a distance or a difference, that will give us that h, our horizontal coordinate for the center, is negative 2. The base of the y term is y minus 1. That will give us k equals positive 1. And r squared is 9, so therefore r is 3. And those pieces of information are enough. That tells us everything that we need to know about this circle. So for example, let's start with the center. The center is x equals negative 2, y equals positive 1. And from the center, we sweep out a circle that is 3 units away. Now to do that, we go 3 units to the right, and 3 units up, 3 units to the left, 3 units down. Those 3 points are called vertices, and we can be sure of them. The rest are formed by sweeping out that constant radius. Our next goal is to write the equation of a given circle. So in both of these examples, we have a circle. That dot in the middle is our center, so we're allowed to say that the center is x equals 1, y equals -1. So that gives us our center. Now from our center, we get to the circle by going 2 units to the right, 2 units up, 2 units to the left, or 2 units down. In fact, 2 units in any direction. But I can use this grid to count out 2 units to find that the radius is 2. So now I use the standard form of a circle, and I plug this information in. And I say x minus 1, because remember we're interested in that difference. We derived that formula, a distance is a difference. X minus 1 squared plus y minus -1 squared equals 2 squared. And we can clean that up. For example, subtracting a negative will become addition, and 2 squared will become 4. So let's clean that up, and we get a much nicer form for this circle. X minus 1 quantity squared plus y plus 1 quantity squared equals 4. In our next example, we've got a dot for the center as well, so we can quickly see that the center is x equals 0, y equals 2. We can count out the radius, 3 units to the right, 3 units up, 3 units down, 3 units to the left. That gives us our radius of 3. We plug that as written into the standard form for a circle. And then, of course, we can clean this up. Anything minus 0 is itself, so we don't need to show that subtraction. And, of course, 3 squared is 9. And when we do that, we get x squared plus y minus 1 quantity squared equals 9. Our next job is to complete the square to find the center and the radius of a circle. Now we have to do this when the equation comes to us in a form that's not standard form. So take a look at this. There's no parentheses here. I can't see that subtraction that forms h and k. And I look at the right side and I see something that clearly cannot be the radius because it's negative. And of course, we get that right side in standard form by squaring the radius. So we're going to go through and complete the square. And this is exactly the method of completing the square that we saw earlier when we were solving quadratic equations. So when it says complete the square, that's exactly what we're doing. So we're going to take the coefficients of the linear terms. So of course I'm talking about the -10 and the -4. And we're going to go through that process. So here is that same equation rewritten with the spaces for the missing constant to complete the square. Just a reminder of how completing the square looks. So we take that -10. We then take half of it. You remember this procedure. Half of -10 is -5. We then square -5 and get 25. That gives us two numbers, the -5 and the 25. We then take -4 and go through the same process. Half of -4 is -2, and -2 squared is 4. The squares are what we're going to add to both sides. So we take the square of the half of the -10, and we take the square of the half of -4. So we're adding 25 and 4. Well, you can't simply go around adding 25s and 4s. If you add 25 and 4 to one side, you must also add 25 and 4 to the other side. And that's all of a sudden looking much, much better because now the right side is positive. -20 plus 25 plus 4 gives us our r squared of 9. So we know that r squared is 9. That's going to tell us that the radius is 3. But perhaps more importantly, or perhaps the other piece of information that we're after is using the halves. So when we looked at the coefficient, the linear coefficient of x, we had a -10. Half of that was -5. And that -5 is going to allow us to factor the perfect square. Similarly, when we looked at the coefficient of the linear y term, that was -4. Half of it was -2. And that -2 is how we factor the y components. Notice that we could make a diamond and we could go through and factor this in the normal way, but completing the square allows us to factor this lickety-split right away quick. Now, this is a difference. A difference is a distance. That tells us that h is 5. And the y component, also a distance inside that base, also a difference. So that's going to tell us that k is 2. So now we've got our center, hk, and we've got our radius, r. So we're going to graph this. Now I'm going to show you how you graph this with pencil and paper. This procedure will help you as we go on and talk about the two other conic sections we haven't met yet, namely ellipses and hyperbolas. So at this point we know the center and the radius. We're going to start with the center. The center is hk is 5, 2. So we're going to put a point there at x equals 5, y equals 2. Then we're going to use the center. The center is going to help us find our vertices. We're going to go 3 units to the right, 3 units up, 3 units down, and 3 units to the left. There's one of those vertices. I've put dots at all 4 of them. Notice that I've also drawn a square as a dashed line. That really helps me draw the circle. And the reason that it helps me is because circles are tangent to the squares that contain them at their vertices. What that means is, just for a moment at the vertice here, that circle is vertical. In other words, it doesn't go straight to that point and then make a right angle turn and then go to the point at the top. It actually comes in like it's landing. It is vertical just for a moment, and then it goes off and up to the top point. And in fact, you can see that that's true for all 4 vertices. So we're going to put a dot in the center and 4 points on the circle as dots. Okay, so let's work through one of these on our own. So here is some equation. It might be a circle, it might be something else, but we're going to figure out what it is by completing the square. So we're going to put it in standard form. That's why we're completing the square, so that we can see h, k, and r. So once we've got it in standard form, we'll be able to graph it almost instantly. So the first thing that we should probably notice is that there's stuff missing. If we want to complete the square, we need to ask the question, what do we have to add to make those into squares, the x and the y component? So we're going to take that m, the coefficient of the linear x term, 2 in this case, and we're going to go through that process. So we're going to take half of it. Of course, half of 2 is 1. Then we're going to square that, and of course the square of 1 is 1. So those are the 2 numbers that we need to complete the square with the x parts. Now we're going to look at the y parts. So the coefficient of the linear y term is negative y. So we're going to go through and do the same process. We're going to start with that negative 6. We're going to take half of it, that's negative 3. And then we're going to square that. Negative 3 squared is 9. And that gives us all the information that we need to complete the square. We're going to add the squares to both sides, and we're going to use the halves to factor. So here we are adding the squares to both sides. So the square of the linear x term is 1. We're adding a 1 to the left side, and we are adding a 1 to the right side. The half of the linear y term is negative 3. We're adding the square is 9. We're adding 9 to the left side, and we're adding 9 to the right side. What we do to the left side, we must also do to the right side. Now those halves, that is the 1 and the negative 3, come into play, and that allows us to factor. So there's x plus 1, and the other half, of course, is negative 3. And that then becomes the coefficient or the constant term in our base. When we do the arithmetic on the right side, that is 6 plus 1 plus 9, we get 16. So that 16 tells us that r equals 4. So when x plus 1 is our base, that tells us that h is negative 1. Remember, we have to think of that as a difference, as the result of subtraction. And similarly, y minus 3 tells us that that difference is 3. So our center is negative 1, 3, that is hk, and the radius is 4. Now to graph this, we're going to start with the center. H equals negative 1, k equals 3, and then of course r equals 4. Don't worry about the others. We're graphing circles right now, so that's selected. And there's the graph of our circle. The center is at negative 1, 3, and the radius is 4. Okay, one more of these we're asked to write in standard form and then graph. That's the simplest way to graph a circle. But before we get too far ahead of ourselves, notice that something here is very different from the previous example. And that is that the squared terms have coefficients. There's a squared term on the x squared. There's a squared term on the y squared. The other thing that you might have to take a second look at is the negative 112. That really has nothing to do with y. That's not counting y's, like the negative 36 is counting x's. That's a constant term, so we should get it on the other side of the equal sign as soon as possible. So let's see what else is going on here. Well, if we've got negative 2's as coefficients on both the quadratic terms, we might want to look at everything else. And the moment we do that, we notice that everything has a 2 in it. And in fact, it would be kind of nice if it didn't have those negatives. So the first thing that I see here is let's get rid of those negative 2's as coefficients of the two quadratic terms, the two squared terms. So let's divide through everything by negative 2. So our first job is to get rid of those negative 2's. So we divided through by negative 2. Notice that negative 112 became positive when it went to the right side, and then negative again when we divided through by negative 2. Now that means that we've still got to find r. Negative 56 has nothing to do with r. Now take a look at the y squared. Notice that it's already a square. I can tell you what k is right now. It's 0, because I could write inside of parentheses y minus 0 quantity squared. The 18x tells me that I have to complete the square on x. So let's go through and do that. We start with that 18. We take half of it. Half of 18 is 9. We take 9, we square it, and we get 81. That square gets added to both sides, so that 81 tells us to add an 81 on the left, and of course an 81 on the right. Well, things are looking better already. That positive 81 is going to win when we subtract the 56 from it. That'll give us a nice positive number for our radius on the right side. So it looks like that gives us 25. So 5 squared is 25. R equals 5. So the radius is 5. Now let's deal with the rest of this. The x squared plus 18x plus 81, we can use the half to factor it. So we're going to write that as x plus 9 quantity squared. So there's our half coming into play. Of course, we're thinking of that as a distance. A distance is a difference, so we have to change the sign and say that h equals negative 9. Now, this is formally how standard form looks, where you show h and k. So y minus k, there's our k equals 0. So now we've got all the information that we need to graph this. We've got the center and the radius. The center is the center is negative 9, 0, and the radius is 5. So our radius is 5, our center is negative 9, 0, so let's put that in. H equals negative 9, so there's negative 9, k equals 0, and our radius is 5. That's a little bit off the screen. We could drag over and look at it a little bit nicer. So there is our circle.